Welcome to tonight's video on implicit differentiation. So far in this class, most functions that we've had with two variables have been expressed in the explicit form, meaning you have y equals some function of x. For example, y equals 3x plus 5. That is, the variable y is explicitly written in the form as a function of x. Now, here, this is implicitly written. It's x times y equals 1. In this equation, y is implicitly defined as a function of x. In order to make it explicit, we would have to divide, by x. So we get y equals 1 over x, or we say this is x to the negative first power. And if we take the derivative with respect to x of x to the negative first, or if we find the derivative, which we say is dy dx, or y prime, that is equal to negative x to the negative second, or negative 1 over x squared. So in this one, if I want to find the derivative of y with respect to x, I can divide, so I get 1 over x squared, which means it's x to the negative second. To find the derivative with respect to x, I make that negative 2x to the negative third, which is equal to negative 2 over x to the third. Now, not all equations are so easy, or do you have the ability to make them explicit? For example, something like this is difficult to express y as a function of x explicitly. So this is where we would come up with a process called implicit differentiation. So let's review where we've been so far. So the derivative with respect to x of 6x to the third, well, that's just a power rule, so that gives us 18x squared. Now here, with respect to x, we could use the chain rule. We could say this is the derivative with respect to x of 4u squared. The u is equal to 5x minus 1, so the derivative of u would be 5. And when you take the derivative, it's 8u times u prime. That's the chain rule, which means it's 8 times 5x minus 1 times 5, which means it's 40 times 5x minus 1, which is 200x minus 40. Here, it says the derivative with respect to x of y to the fourth when it tells you what y is, 2x plus 3. So this is the same as saying the derivative with respect to x of 2x plus 3 to the fourth. So this is another chain rule where u is 2x plus 3 and u prime is 2x, or 2, sorry. So therefore here it would be u to the fourth, and then when you take the derivative, it's 4u to the third times u prime. So it gives you 4 times 2x plus 3 to the third times 2, which gives you 8 times 2x to the 2x plus 3 to the third. And you do not need to raise anything to the third power or square it. I simplified this one up here because it was to the first power. Now, if you don't know what y is, so here, for example, we're taking the derivative with respect to x of u to the fourth, and u is equal to y. If you don't know what y is, then u prime would be whatever the derivative of y is, dy dx. So here, when you say it's 4u to the third times u prime, it would be 4y to the third times dy dx. So basically, if the variable does not match what you're differentiating to, in this case, you're differentiating with respect to x, then you basically have to add the derivative of that variable, which in this case is dy dx. You multiply by that because it's the chain rule. So here, when you have a sum, you can split it up into two separate derivatives, the derivative with respect to x of x, plus the derivative with respect to x of 3y. The derivative with respect to x of x is just 1. 3y, if you do the chain rule, remember this is like 3u, u is equal to y, u prime is dy dx. So then the derivative would be 3 times u prime, which is dy dx. So it's just 3 dy dx. And that is your final answer. Here you have a product rule. So this is the derivative with respect to x of x times y squared. So actually, sorry, you have a product rule. So u is equal to x. So u prime is 1. V is equal to y squared. V prime would be 2y times dy dx, because it's a chain rule. So when you do the product rule, remember you multiply u times v prime, so it'd be x times 2y dy dx plus y squared. And then when you simplify this here, remember you write the numbers first and then alphabetical order, so it's 2xy dy dx plus y squared. Now in number 7 and 8, we will say where a and b are constants. I forgot to add that in. So if you know the letters are constants, like a and b here, then when you take the derivative with respect to x of 8x minus the derivative with respect to x of a, and the derivative with respect to x of 3x squared, plus the derivative with respect to x of b to the third. So here it's 8. If a is a constant, then it's just 0. The derivative with respect to x here of 3x squared is 6x. And then this is also 0 because it's a constant. So it's equal to 6x plus 8. And here the derivative of a times b, it would just be 0 because it's a constant. So how to differentiate equations. So when you're solving for something, you want to differentiate both sides of the equation implicitly with respect to x. So for example, I'm going to take the derivative with respect to x of each term. That is the first step. That's what the d over dx means, is that I'm taking the derivative with respect to x of each term. All right, the derivative with respect to x of x squared is 2x, right? Because if the letters match up, you just take the derivative, no need to add the dy dx, because the y is not, this is not a y. So here you have a y and an x. So when you take the derivative, doing the power rule, it's 6y squared, but then you have to multiply by the dy dx, or the y prime. Here, the derivative is 4, but then you also have to multiply by dy dx. And it's equal to 0 because 2 is a constant. So now it wants you to find dy dx, so you're going to move everything over to the other side that does not have a dy dx. So in this case, you're going to keep the negative 6y squared and the 4 on one side, and I'm going to move the 2x to the other side. So it's going to be negative 2x. Then to solve for dy dx, I'm going to factor it out. And then I'm going to divide. Now the only thing left to do would be to simplify this. And since the denominator can be factored by 2, and both of them have a negative. So notice if I take out a negative 2 here, I get 3y squared minus 4. So you can cancel the negative 2's, and you're left with x over 3y squared minus 4. That is the derivative of that equation. All right, so now let's take it a step further and find the equation of the tangent line to the graph of x squared plus 4y squared equals 4 at this point. So remember, we want to take the derivative. So we're going to take the derivative with respect to x. Of each term. Then, when we take the derivative, here we get 2x. Here we get 8y, but then we have to multiply by dy dx, because it's a y and we're differentiating with respect to x. And then this is 0. So now we want to solve for dy dx, because that's the slope of the line. Remember, derivative is slope. So we're going to move the 2x over. Then divide by 8. So this is going to give you negative x over 4y. That's the derivative. So remember, when you write the equation in point-slope form, you're going to go y minus y1, so in this case it's plus 1 over rad 2, equals, and then we take the slope times x minus x1. So now we need the slope. So the slope is the derivative. So what we have to do is put these values in. So negative square root of 2 over 4 times negative 1 over square root of 2. So it gives you negative square root of 2. And then this is negative 4 over the square root of 2. So then you multiply, and that gives you negative 2 over negative 4, which is 1/2. So the slope is 1/2, and there is your equation of the line. So the last one here, it says to determine the slope of this graph. So this one's got a lot going on. So let's take the derivative. So we're going to take the derivative with respect to x of 3 times x squared plus y squared squared. And then you're going to take the derivative with respect to x of 100xy. So here we have a chain rule. So we'll let u equal x squared plus y squared. That means the derivative is 2x plus 2y dy dx, because remember you're differentiating with respect to x. So when you do the chain rule here, remember this would be 3u squared. So when you take the derivative, it's 6u times u prime, which means it's going to be 6 times x squared plus y squared squared, 6 times x squared plus y squared, times the derivative, which is 2x plus 2y times dy dx. Okay. So here when you FOIL, we'll FOIL this out. So here I'm going to FOIL it this way first. I'll multiply by 6 at the end. So you get 2x to the third, and then plus 2x squared y dy dx. And then here you get plus 2xy squared. And then here it's plus 2y to the third dy dx. And then multiplying by 12, you get, or 6, you get 12x to the third plus 12x squared y dy dx plus 12xy squared plus 12y to the third dy dx. Okay, so that's the left side. This is a product rule. You can say u equals 100x, v equals y. So the derivative here is 100. Derivative here is dy dx. And when you do the product rule, remember, you're going to multiply u v prime, so 100 dy dx, or sorry, 100x dy dx, plus, and then it's 100y. So now, just like before, we want everything with a dy dx on one side. So I'm going to keep these two terms on this side. And I'm going to move the 100 over, 100x, sorry. And then everything else is going to move to the other side. So I have 100y minus 12x to the third minus 12xy squared. So then you're going to factor out the dy dx. And then you're going to divide. So now you're going to divide by this whole thing. Now, the only thing you can do is to simplify it is that every term is divisible by 4, right? So you could make it 25y minus, 25y minus 3x to the third minus 3xy squared over 3x squared y plus 3y to the third minus 25x. So now you're just going to substitute, because you're trying to find the slope at the point 3, 1. You're going to substitute 3 for x and 1 for y. So just doing some substituting. And you're going to get 25 minus 27 times 3 is 81 minus 9 all over 9 times 3 is 27 plus 3 minus 75. So it's negative 65 over 30 minus negative 45, so it's 13 over 9. That is your slope at that point. All right, I hope you enjoyed the video, and if you have any questions, come see me. Have a good rest of your evening.